Hi guys, we've already done ray diagrams on concave and convex mirrors, and if you've not happened to see the video, please go ahead and look at it. It's in the description below. And today we would like to do some numericals on concave and convex mirrors. So let's get started. Now what we'll discuss is the sign conventions for the concave and convex mirrors. Okay, so for 9th and 10th standard, the way I would like you to remember the sign conventions is like this. At the pole, you think it is the origin and draw the x and y axis. Okay, so here we have the pole, we have drawn the axis. So this is the positive x axis and this is the negative x axis. Similarly, this is our positive y-axis, this is our negative y-axis. Okay, so this is our xy plane. And then what do we do if I want to measure something? If anything is in the first quadrant, we call this as the first quadrant. We say all the x is going to be positive, all the y is going to be positive. So any point here will have positive x and positive y. It's called the first quadrant. But you look at our object and image distances, right? We are saying this is our u, which is our object distance, right? So if you look at it, it is on the negative axis, right? So as a sign convention for concave mirrors, this is the distance we are going to measure. This distance is negative, so u is considered as negative. So the sign convention for u is going to be negative. Okay, what about f? F is the focal length. For focal length, we say, hey, this is going to be our focal length f. Once again, this focal length is on the negative axis. So for a concave mirror, the focal length is going to be negative. What about the image? Okay, in this particular case, this distance v is also on the negative x-axis. Therefore, we say v is also negative. So please remember this sign conventions. Object distance, which is on the x-axis, negative x-axis, minus focal length is always negative for the concave mirror. This v sometimes could be positive. Okay, there is only one position for the concave mirror where you put this between f and p. If you put the object between f and p, you are going to get the image somewhere here. So if for that particular position of the object, the v is going to be positive. Okay, so apart from that, all other v will be negative. So now let's look at the convex mirror. For convex mirror 2, the u is on the negative x-axis. So we will consider u to be negative. What about v? We know that for a convex mirror, the image is always going to lie on the opposite side, right? It's always going to be a virtual image. Therefore, this distance will be on the positive x-axis. Therefore, v is going to be always positive. Okay? And what about f? Focal length is this side. Okay? So the focal length for a convex mirror is always going to be positive. Okay, so it is very essential that you remember the sign conventions of this, and this is an easy way for you to do it. It's not necessary for you to mug it up. By considering the pole of the mirror to be the origin and drawing the x-axis and y-axis, very easily you will be able to identify the sign convention that you will have to remember. I hope you guys have followed this. Now we got all the basics out of our way. Let's try our hand at numericals, okay? So if you look at the numerical, we have told that the focal length of the concave mirror is 15 centimeters and the object is placed at a distance of 30 centimeters in front of the mirror. We are supposed to find where is the image formed. Okay, so let's quickly write down all the details that are given there. Okay, so we have the focal length given. Focal length is given as 15 centimeter. And the second thing is we have been given the object distance, right? So what is the object distance? It is designated by U. So U has been given as 30 centimeter. Okay. And what are we supposed to find? We are supposed to find out the image distance V. Okay. So this is what we need to calculate. Right. So as soon as you extract this data and put it, the immediate thing that you need to do is verify if the sign of FU are properly taken or not. Okay. So it is a concave mirror. So first and foremost is make a note of that. So what have we learned in the sign conventions? Concave mirror, F is always going to be negative, isn't it? So take this F as negative. And what did we discuss about concave mirror and object distance? Whether it is concave or convex, object distance is always going to be negative. Okay. So while they have given you the dimension 30, they will not mention this sign. You will have to extrapolate that. You will have to understand the numerical and supply the sign convention. Okay. Now there is something which I have to tell you. How are F, U and V connected with each other? Okay. So for mirrors, there is going to be one formula. That formula is 1 by F is equal to 1 by U plus 1 by V. This is one formula that you have to use for both concave as well as for convex mirrors. So it's very important that you remember this. Okay. Now what we do, we have the formula, we have the values, let's just calculate it. Okay. So I want V, that means I want 1 by V. So I will simply say 1 by V is equal to 1 by F minus 1 by U. Simple and straight. Okay. Now what we do, we have to plug in the values. F is minus 15. So when you put F is minus 15, the whole thing becomes minus 1 by 15. And then this is the formulas minus, keep it as it is. And then U happens to be minus 30. So 1 by minus 30. Okay, so this minus is the formulas minus. Please don't miss that. And then we kind of solve this 1 by 15 plus 1 by 30. So the LCM is going to be 30. We'll do one thing. So if you see here, this LCM is going to be 30. So this is going to be minus 2 plus 1, or this is minus 1 by 30. Okay, so that is 1 by V. Therefore, what is going to be V? This simply means that V is going to be equal to minus 30 centimeter. Okay, so the image distance is minus 30. See, the sign automatically came. You didn't need to supply any sign now. Okay, you just put it in the formula and you got the answer. V is equal to minus 30 centimeters. So this is how we solve the numericals with respect to convex and concave mirrors. I hope you followed this. So let's now try our hand at one of the convex mirror numerical. Okay. So in the given numerical, we are told that the focal length of a convex mirror is 15 centimeter. So let's make a note of that. The focal length F is equal to 15 centimeter, and here they have given the object distance as 30 centimeter. So we will make a note of that as well, and we are once again supposed to find the image distance. Okay, so image distance is designated as V, so we have to find out what is the image distance. So you must remember that these details are given for our convex mirror. Okay, so what is the first step we do? After we extract the data, we are supposed to put the sign convention, follow the sign convention and put it. Focal length of a convex mirror, what was it? focal length of a convex mirror is always going to be positive. So this is going to be plus 15, because we said that, if you have a convex mirror, this focal length is always on the right hand side. So it's going to be positive for this. U is always going to be negative, whether it is convex or concave. Okay. So we put that, and we have to find out V. So we use the same formula which we discussed before. 1 by F is equal to 1 by U plus 1 by V. It doesn't change whether it is convex or concave. We have to find V. We say 1 by V is equal to 1 by F minus 1 by U, and we take the value of F. Now it is plus, so this is 1 by 15 minus 1 by U. U is again minus 30, so this is going to become 1 by 15 plus 1 by 30, and this is going to be, if you take the LCM as 30, this is 2 plus 1, 3 by 30, which is going to be equal to 1 by 10. Therefore, 1 by V is 1 by 10, which means that V is equal to 10 centimeters. Okay. So, what does that V is equal to 10 centimeters with a positive sign mean? Right? That means that the object is, the image is forming on the right hand side. Okay. So, the positive sign simply means that the object was somewhere here, but the image is forming on the other side. Okay. So this is how we apply the sign conventions, and we compute object and image distances for both concave and convex mirrors. I hope you followed this. Thank you so much for watching our videos. Please like and subscribe to our channel. Be sure to share it with your family and friends, and don't forget to visit our website www.cogitarelearning.com, where you have linked to all the videos that we have been recording so far. Thank you once again.